today's class we'll be looking at the derivative of a function from first principle, how to differentiate a function from first principle. So let's start. Let's say we have a function, let y equal to f of x. Assuming this is a function, or let's say this is a function y equal to f of x. Now let's add the increment of x, right, to this, and also since we are adding increment of x to this, we also add corresponding increment of y to this y here. So if you add the increment of x and y, we're going to have y plus what? Delta y. Now we say, I said let's add the increment of x to x here and increment of y to what? To y. So if you do that, increment of y plus y, we're going to add this is equal to, in place of x here, add the increment of x. If you add the increment of x, becomes what? X plus what? Delta x. Add the increment of y, add the increment of what? X. After adding the increment of x, the next step now is to subtract y from both sides. Subtract y from both sides. So you have to subtract y. Subtract y from both sides. This will give us y plus delta y minus y, right? Which is equal to f of x plus delta x, close the bracket, minus y. Now y minus y give us 0. That means these two are out. We are left with what? Delta y. Now this will be equal to f of x plus delta x, close the bracket, minus. Now this is minus y. Here we said that y is equal to what? F of x. Since y is equal to f of x, this becomes minus f of what? X. In place of y here, substitute y as f of x. So if you do that, you are going to have this. Now, after subtracting y, putting it as f of x, the next step now is to divide through by delta x. Divide through by delta x. So if you divide through by delta x, that is divide through by delta x. So let's divide through by delta x. This is delta y. So I'm dividing by delta x. This becomes delta y over delta x. So I'm going to have delta y over delta x equal to, now we are dividing through by delta x. That means everything here will also be over delta x. So this becomes equal to f of x plus delta x minus f of x. Everything is divided by delta x. So we have this. After dividing through by delta x, we have this. After dividing through, let's say to take the limit delta x tends to what? 0. Take limit of delta x tends to 0 of both sides. Take limit of delta x tends to what? 0. Now limit delta x tends to 0 here, I'm going to have limit delta x tends to 0 of delta y all over delta x is equal to limit delta x tends to 0 of everything here, which is f of x plus delta x minus f of x divided by delta x. So we have this. Now the limit of delta x tends to 0 of delta y all over delta x is equal to y ds. I said that when delta x tends to 0 of delta y all over delta x is equal to dy x. So if you take the limit of delta x tends to 0 of this, it will give us dy ds. If that is the case, if the limit of this gives us the y ds, that means everything there becomes the y ds is equal to this. So we are going to have dy all over dx is equal to lim delta x tends to 0 of f of x plus delta x minus f of x, everything here divided by delta x. So from first principle, these are the procedures we follow. If you have a function where y is equal to f of x, right, add the increment, then follow these procedures so that at the end of the y ds is equal to what? This particular formula from first principle. So let's take our first example